All right, this is Ubaid on behalf of electronics, and in this video, we're going to talk about Bernoulli trials and binomial distribution. Okay, now, when it comes to binomial distribution or binomial experiments, okay, these experiments have to do with Bernoulli trials. And what are Bernoulli trials, you may ask? So these are small little experiments like tossing a coin. Okay, it could be a clinical experiment. Okay, it could be a clinical study on a medication, for example. Okay, it could be um, heads and tails. Okay, it could be rock, paper, and scissors, for example. All right, so Bernoulli trial. A Bernoulli trial has to do with experiments or trials where success and failure rates are equal. Okay, where success and failure rates are equal. All right, so say for example, P plus Q equals 1. So therefore, P equals. So if you're talking about a binomial experiment, and Bernoulli trials do have to do with binomial experiments, okay, P has to do with your success rate, and Q has to do with your failure rate. Okay, so P equals success rate, and Q equals failure rate. All right, so if you were to try and get a basketball dunk, okay, your failure rate and your success rate would be the same. Okay, considering that you are fully capable of getting that ball in the net. All right, so that has to do with success and failure rate, where success rate equals failure rate. Okay, they're both equal. Now, when it comes to binomial experiments, okay, binomial experiments have three characteristics. Okay, number one, this has to do with binomial experiments. Okay, you have fixed number of trials. So fixed number of trials. Okay, next you have possible outcomes. So success and failure rates are the same. All right, so this is where P plus Q equals 1. And the last possibility, so this has to do with binomial experiment as well. Okay, your n number of trials are independent and are repeated. Okay, so N number of trials. N is a variable that stands for number of trials. They are independent. Are independent. Okay, it's an independent variable, such as your x-axis. So over here, if this is your x, this is your y, this is number of trials over here. All right, and over here you would have either P or Q, success or failure. Okay, so number of trials are independent, okay, and repeated, okay, and repeated using identical conditions. All right, and this is just to be fair, okay, so that you're not biased when it comes to results, okay, repeated using identical conditions. Okay, so just like a basketball shot, you could have a clinical experiment. Okay, these clinical experiments may have n number of trials, a certain number of trials, and these trials are independent of results, whether failure or success. Okay, not to mention the probability of success and failure is equal. Okay, P plus Q equals 1. And you may have fixed number of trials, which means that the study coordinator, for example, may decide to go ahead with a fixed number of trials. Okay, may um, let's say test out, say, 10 or 15 participants. Okay, so fixed number of trials, okay, and number of trials. And these are independent and repeated using identical conditions. So the conditions will be the same. All the participants will be exposed to the same conditions, and so on and so forth. So this has to do with your binomial experiment, which is connected with your Bernoulli trials. Okay, on behalf of Electronics, this is Obey. Have yourself a great day.